We're going to have a look at skewness, how skewed a distribution is, how skewed some data is, or whether it is in fact symmetrical. We're going to look at doing this both by inspection and by calculation, the formula for which is in your formula book, so you don't need to memorise it. So let's start off with a normal distribution, also sometimes called a symmetrical distribution. Okay, so this, if it was symmetrical, would be symmetrical around this central point here, as though that were a mirror point, and it's the same on both sides. And that is called symmetrical, or sometimes also called normal distribution. And for symmetrical and normal distribution, you've got that the mode and the mean and the median are all that line here. So they're the same, okay? And that's your symmetrical or normal distribution, which is this picture here, that has no skewness. It's not skewed, it is symmetrical around this point. But we're going to look at when it is skewed. Let's say this is what your curve looked like. So if you have a look, you've got a lot of data here and then less data here. Okay, so you've still got your mode, your median and your mean. Your mode is always at the highest point there, so that's your mode. Your median is going to be halfway along, so it's going to be more like this, median. But your mean is going to be really affected by these numbers over here, okay? So your mean is going to be really affected there, so it's going to be pulled up because of the way that mean's calculated. It adds up, including those large values, so it's going to be skewed by those numbers, okay? So that is going to be skewed that way. Now, sometimes people get confused, is this positive or negatively skewed? Well, I've had a number line here with 0 in the middle. These are my negative numbers and these are my positive numbers. So likewise here, this would be my negative, this would be my positive, and you can see the skew, the dog from the previous bit, its tail is here. So this is positively skewed. This is positive skew, okay? And this is when the mean is really affected, so it's the biggest, then the median, and the mode is the smallest. So you could write that like mean is bigger than median, is bigger than mode. And that is positively skewed, where the mean is the largest here. And I've also included here a box plot that also has positive skew, so the tail is in the positive direction here. You see the median is lower than a lot of the data here. Okay, and then negative skew is the same, but the other way around, so let's have a little look at that. So here's a bit of a summary. I've got the normal one, I've got negative and the positive. Pause for a minute, are you able to say which one is negatively skewed and which one is positively skewed? Hopefully you're able to say that this one in the positive direction is positively skewed and this one is negatively skewed. And if you notice in the negatively skewed one, the mode is still the maximum point, the median is still halfway along, but the mean is being skewed by these negative values, the smaller values there. So that is negatively skewed. So that's doing it by inspection, but we also want to do it by calculation, and you're given a formula in your formula book, which is this. What this means is we're looking at the difference between the mean and the median, so that's this difference here, or the difference here. We're timesing it by 3 and then we're dividing it by standard deviation, which we've recently looked at. So thinking how many standard deviations fit in 3 of those. Okay, and this tells you how skewed it is. Now obviously if it's negative, it's negatively skewed, and if it's positive, it's positively skewed. And the bigger the number for it being positively, the stronger the skew. So basically, the farther apart this is, the bigger the skew, and the further apart this is, the bigger the skew. But of course, with negatives, a bit different. So -4 is a stronger negative than -1. That's a weaker negative. Okay. So we'll have a look at an example. For this worked example, we're given some shoe sizes of 100 students in Year 8. the mean shoe size, the median shoe size, and the standard deviation. And we have to calculate the skew. So I'm going to use the formula given to me in the formula book because it tells me calculate. Okay, 3 lots of the mean minus the median divided by the standard deviation. And the amazing thing is this question's given me all that information. I don't even need to use my calculator to calculate those myself. So I'm going to have a get at that first. So 3 lots of the mean, 4.94, minus the median. Now I'm going to notice there, that's going to be a negative number, so it's going to be negatively skewed. If I imagined my thing here, I've got my median is here, and my mean, so if my median is 5, my mean is smaller than that. My mean is at 4.94, so it's going to look like that. That was a bad picture of it, but it should be negatively skewed here. Okay, so, and it's all divided by the standard deviation, and if I just pop that into my calculator, I'm going to get negative 0.11 to 2 decimal places. So I'm right, it is negatively skewed because obviously this bracket is going to give me a negative thing, but it's not very negatively skewed because it's only a little bit negative. So when I'm interpreting it, I need to say it has, this distribution has weak, negative, skew, and I'd say whether it was strong or weak, and positive or negative. Okay, and it just means that the mean is really close to the median, so there's not much skew. It's close to normal distribution there. It's not far off. Have a go at some questions yourself now.